Hi, I'm Marcin.
Hi, I'm Wojciech.
Hi, I'm Yanrong.
Hi, I'm Hussein.
Hi, I'm Matthew. We are Ketzlock team, and this is our data engineering final project.
Our aim was to create a data platform for extracting, transforming, and loading data from a Postgres database called ToteSys into a data warehouse hosted on AWS. The system runs on a 30-minute schedule.
This diagram represents our project. We start with extracting data from the ToteSys database. The first Lambda handles data extraction and upload it into the Ingestion S3 bucket. Files in the ingestion bucket are stored in JSON format. The second Lambda is responsible for transforming the ingested data and uploading it to the process S3 bucket. The files in the process bucket are stored in Parquet format. The third Lambda takes the process data and inserts it into the data warehouse. The data in the data warehouse is then optimized for analysis. To visualize the data, we use Look Studio. To build our infrastructure, we use Terraform. To make sure each Lambda gets invoked in the correct order, we use an AWS step function. Here you can see our buckets and our file structure. Each Lambda has its own logs to monitor progress, and if an error is logged, we receive an email notification.
Let's have a closer look at the extraction phase. First of all, we connect to the ToteSys database. Then we use a dynamic filter in our query, which returns only the data which hasn't been processed yet. The data is pulled from the database and passed to the process and upload functions, which are responsible for saving the data into the ingestion bucket in a JSON format. We update the timestamp so we can use it as a filter for the next Lambda invocation.
Now let's move on to the transform phase. Here we start by retrieving data from the ingestion bucket based on the timestamp, which acts as a filter similar to the one from the extract phase. The new data is then passed to the transform handler, which modifies the data to fit the star schema format. One problem we encountered in this phase was handling the date dimension table. Our first approach was to dynamically create dates based on the sales order table, but due to the long processing time required for this, we decided to use a static date range, which significantly improved performance. We then needed to ensure that the Lambda only created the date dimension once and did not recreate it if it already existed. After forming the star schema, we converted it into Parquet format and uploaded it into the processing bucket.
The last step is the load phase. From the processed bucket, we extract the latest version of the tables stored in Parquet files. Then we insert the new records into the data warehouse and save the timestamp to keep a record of the last insertion. This is done to prevent the insertion of duplicate records. The data is now properly saved in the data warehouse and ready for analysis. And here's the overview of the final star schema.
We use Looker Studio to showcase and visualize the data. This creates an easy-to-use platform for reviewing the data in a variety of metrics and combinations, allowing the in-depth analysis of business performance. Every slide is connected directly to our data warehouse, which allows to view the data in real time. The first few graphs are referencing overall sales performance, like revenue based on different factors, for example, revenue per staff, per counterparty, or per location, in a format of nice GEO map. Here we have several graphs which indicates the overall revenue received by ToteSys, and some specific information about December 2024.
Our project incorporates automation through a CI/CD pipeline and infrastructure as code with Terraform, maintains over 90% test coverage using PyTest, and adheres to PEP 8 standards for clean, readable code. Thank you for watching.